Welcome to all to the next section of the Brainiacs revision series, electric charges and electric field, part 2 video. First video we have discussed 10 questions from electric charges and electric field. We have discussed each question by NCERT, section by sections we have discussed, which means we have taken each section and we discuss what is the key point or what is the theory behind the question. Then we enter into the solution. The same method we are following here. Those who have not seen the first part of the video, I request you to go and watch the first set of, which means the first 10 questions from our playlist. If you go to Brainiacs YouTube channel, you can see that the electric charges and electric field complete theory lessons which I have taken is already available in the YouTube channel. There are more than 26 videos are available for this complete electric charge, electric field and electrical potential and capacitance. So you can go and watch of this video. Then you can also come here. Also, this is the second part of the question discussion. So we are doing section by section of NCERT. First part of the video is already available. That is 1 to 10 questions. And in this part of video, we are going to cover 11 to 20 questions. Next 10 set of questions. Here, the question is mainly focused on two areas. One is the Coulomb's law. Coulomb's law is a big topic. There are a lot of questions. First part, we are also covering Coulomb's law and force due to multiple charges. Here also we are covering certain part of Coulomb's law, and another major section in this area is electric field. So definitely this video and the upcoming next video, that is part 3, question number 21 to 30 will also cover electric field. So here two sections, once again Coulomb's law and electric field. So question is focused on this part from NCERT sections. So without wasting the time, we will enter into our second part of the video. Once again, welcome you all to our second part of the video of electric charges and electric field. Question number 11 in front of you is already. So this question number 11 is taken from NCERT section number 1.5, Coulomb's law. Let's read the question. Two small spheres, each having the charge plus Q, are suspended by a insulating thread of length L. Two spheres, we have two small spheres from a hook. This arrangement is taken into a sphere, into a space where there is no gravitational effect. We have seen lot of YouTube videos, right? When we are going to space, there is no gravity. So what will happen? Every body will like floating state, not attracted towards earth because there is no gravity. So one float state. You can see a lot of people are already visited space and how they are managing. So if you are drinking water, what will happen? The water should come down, right? But if you are drinking water in space, the water will go up. So it's very difficult to live there and very difficult to adapt to such situations if people are going from earth to space, because it's just the opposite reaction happening. In earth everything is coming down, in space everything is going up. That's what we feel like, a floating atmosphere in space. Okay, let's back to the question. This arrangement is taken into a space, so where gravitational field is 0, no gravity. No gravity means acceleration is equal to 0. That's the meaning. Then angle between two thread and the tension in each will be. What is the angle between the two thread and the tension? So first, this was in air. In air we have to spread like this. Then we have taken into space. So this is like this here because we have a force called mg is acting downward. That's what it is hanging. If there is no mg, what will happen? This will move upward, this will move upward. So the final structure is look like this in space. In space, the final structure is look like this. So because of the force only, these two threads are hanging like this. Okay, this hanging is due to the force which is called mg. If no forces, what will happen? This is what is happening in space. This will not hang, this will just like float. Okay, so this is what. Now what is the angle between, in earth this is the angle called theta, in space definitely what is the angle will be here, it is called 180 degree. So answer is 180, it is very clear. From 180 we have two options are available. Now we have to find out whether answer is 1 or answer is 4. Okay, so let's learn some theory behind this one. First, a theory is nothing but the key point or the theory behind this question is Coulomb's law. You know, F is equal to 1 by 4 pi epsilon 0. This normally we have written as what? In first part of the video we have learned it is called K. Q1 Q2 by R square. And second one is no gravitational effect. This is a second hint which is given in the question. What is no gravitational effect mean? Acceleration due to gravity is equal to 0, which means mg equal to 0. This is the two key point or the two theory point which we have to understand or which we have to learn from this question. Next, we are going to analyze this part. Okay. So we have three set of diagram I have drawn. Don't be get much confused. This is the first set of the diagram. This is given in the question. It is like a two threads which is hanging over here. Next, we are analyzing what will happen if it is taken into string. As like I told, here this is a positive charge, this is a positive charge. Both the charges by default, if the question is given charges means you take both are positive charges. What will happen? There is a repulsive force. So both the charges move left and right direction. That's why we have marked as F here. And because of the F, what will happen? Two bodies will be moving like this. And here, one important point, there is no mg. Why there is no mg? Now you know the answer. The question is already told. You have no gravitational effect on space. So no gravitational effect on space means mg equal to 0. mg equal to 0. That's what I given a cross mark here. So it is both are 0. No mg is here. Next, so at the space the structure is looked. One charge here, one charge here. Already in the question it is given the thread length is called L. Now the distance between the two thread is how much? L plus L, 2L. Now this is a 2 charge. Distance between the two charge is equal to 2L. Total distance is 2L. So now we know the angle equal to 180 degree. I already told this one because both are stretching like this and there is no mg in the downward direction. So now we are applying the Coulomb's law. 1 by 4 pi epsilon 0 q1 q2. Okay, so here we don't want to write q2 because just they are given it's called charges. So we have to just write just write q1. So this is enough. So q into q. Okay, so q1 they have not told like q1 and q2, so I just taken q into q. So each of the charge, which means this charge is q, this charge is q. Here also it is q, here also it is q. It's not q2. Here also it is q, here also it is q. Everywhere it is called q charges. Okay, now the product of the charges, so q into q square, and distance between them L plus L, total is R square formula. How is the formula? K into q1 q2 by R square. So this R square is nothing but 2L the whole square. So this is the answer. Angle equal to 180 degree and the force equal to q into q divided by 2L square. Let's look into the option. What is the option which is matching? Yeah, so already we told we have either option number 1 or option number 4, but in option number 1 only 2L square will be here. Option number 4 L square, and angle we already know 180 180 180. So 180 180 180, three options will be here. So 1 by 4 pi epsilon 0. Here you will be very careful about option number 3. Here it is given 2L square. 2L square is not equal to 2L the whole square. Okay, so this is 2L square. This is nothing but actually what is this is one? This is 4L square. So option number 1 is the correct answer, since we have the distance between the charges is 2L and a 2L in the whole square. So it becomes 4L square. So option number 1 is the correct answer for this question. It's very important. Okay. So let's mark. So 1 is the correct answer for this questions. something happens. No. Okay, so all's done. Okay, fine, good. So we have q square. Okay, so option number 1, remember it is 2l square, not l square. Okay, very important on this part of the question. Okay, what we have discussed. I think my color is gone here. Let me make it as beautiful colors. Normally I will put the questions in a green box. So this color is gone here. Let me make it as a green box. Oh, oops. So that it's easy for to analyze. Okay, now it's perfect. Okay, so let's move to the next question. Question number 12. Question number 12 here. This is a, if I remember correctly, this is a NEET, previous year NEET question. So let's read this question. 3 charges, minus q1, where is minus q1? Here, minus q1, q2 here, and q3 here are placed as shown in the figure. Question is asking x component of the force. X component of the force on where? On minus q1. X component of the force on minus q1. What is a total force on minus q1? But that is only x component, no y component. What is mean by x component? Suppose, for example, see, you have a force like this called F, and you can resolve this force into x component, you can resolve this force into y component. This normally we have written as fx. This normally we have written as fy, fx component of force. If this angle is theta, then we write it as fx equal to f cos theta. F cos theta. So this is the force coming nearer to theta, So it is called fs cos theta. So what this will come? F sine theta. Fy equal to f sine theta. So it's important. So the thing is like the side f is the total force. We can resolve f into 2 component, f cos theta and f sine theta. So where cos theta will come? The side adjacent to theta. The side adjacent to theta means this side. So this side, I'm highlighting this side again and again and again. So this is called f cos theta. So the, of course, the 90-degree other component is called f sine theta. It's very important. So we learned some important theory behind this concept, but I forgot to mention one thing. This question I have taken from NCERT, section number 1.6, forces between multiple charges. NCERT section number 1.6, forces between multiple charges. Important, Anna. This question comes from that particular topic. We'll look into the key point behind this question. Key point means the learning or the theory behind this particular problem. Okay, let's see. Forces on a charge from a system of charges. Forces on a charge from a system of charges means many charges are there and you have to find force on a charge is equal to vector sum of the all the forces. For example, let's say I have one charge here, I have one charge here, I have one charge here. Now I want to calculate the forces on charge number 1. So what should I do? The force from this charge, say F, force from this charge is F. So the vector sum of the two forces we have to calculate. Vector sum means we have to do F cos theta, F sin theta. If it is in the same direction, we will add it. If it is in the opposite direction, we will subtract it. And if it is making, so for example, let's explain one thing. If we have two forces, say F1 comma F2, then F net total force, this is called a vector sum or a direction, same direction, we will add it, F1 plus F2. If you have two forces, say F1 comma F2, but both are, if you have two forces, let me write here, if you have F1 here and F2 here, both are in opposite direction. So what is F net? F net equal to F1 minus F2, or you can write F2 minus F1, both are correct. Both are correct. And suppose if you have a force like this, F1 into F2, angle between them is theta, then you will write the resultant of two forces is, what you will write? F1 square plus F2 square plus 2 F1 F2 cos theta. Theta is angle between them. Okay. So that is called the vector sum. If it is in same direction, you will just add it up. If it is in opposite direction, you will subtract it off. Okay. Maybe let me write it as a notes. If it is, you have f1 in this direction and f2 in this direction. So what is f net? F net equal to f1 plus f2. This is one case. So case number 1. In case number 2, I am writing, you see f1 is in this direction and f2 is in this direction. So what you can write, f net equal to f1 minus f2, or you can also write f2 minus f1. Another, the third case, we have f1 in this direction, we have f2 in this direction. This is called vector sum. This f net is called the vector sum. So f net equal to, I will write root of, tell me, f net equal to root of f1 square plus f2 square plus 2f1 f2 cos theta. So these three cases are called the vector sum. Case number 1, case number 2, case number 3. So these three cases are called the vector sum. If it is in same direction, we will add it up. Opposite direction, we will subtract it in any order. Doesn't matter. And the third one, f1 f2, angle between them, 2f1 f2 cos theta. Okay, next, one important other concept we are going to also learn for this problem on theory point. We have to understand what is called, listen very carefully. So here we have a q1 charge and here we have minus q2 charge, So this charge sign is nothing but minus. So let me highlight it. This is the minus charge, minus q2 charge. So now suppose I'm going to analyze the forces on q1. I'm going to find out force on q1. So what will happen? The forces on q2. So what will happen? Force on q2 means q1 will attract. So q1 will move in this direction. Q1 will move in this direction because q1 is positive and this guy is negative. So what will happen? Q1 will attract. Q1 will attract with a force called F, like this one. Now, if I'm writing the formula, I should write F equal to Q1 Q2 R square. And what is the direction of force? From left to right. But while solving the problem, never write like this. This is wrong. Q1 into minus Q2 by R square. No, that is wrong. That is wrong. While you are solving the problem, it is very important that you are writing only the magnitude, not the sign. Q1 Q2 by R square. That is correct. This is correct. This is wrong. This is pakka wrong. Why it is wrong? Because the sign of the charge giving you the direction of the vector. The direction of the vector F. It's only give the direction of the force. It's not giving the magnitude. It has no impact on the magnitude. So you should understand while writing the formula, while solving, you have to take F Q1 into Q2, not Q1 into minus Q2. That is wrong. Okay, now we'll go into the solution. So this is a diagram given. We need to find out the total force on the Q1. Okay, so I have written an important point here. Never use the sign of the charge in equation. It's only used to represent the direction of force. I already told this one. So same thing. Next, we are going to find out the force on the Q1. See, let's analyze. Force on Q1 means force on Q1 means you are standing here. Next, once you are standing here, you are looking what happened to you. Because of minus Q3, you cannot go towards minus Q3. What you will go? You will be pulled by, you will be pushed by. You will be pushed by minus Q3 in this direction. In this direction. So what is the force? K into Q1 Q3 divided by A square. I already told you never take a sign. So that's what I intentionally written here, plus and plus. Even though charges are minus and minus, I know, but never take the charge. Never say minus Q1 into minus Q3. No, always take positive charge. Q1 into Q3 divided by A square. Now, if you're asking the direction of the forces, yes, this is the direction of forces, because due to minus Q3, minus Q1 will be pushed away. Because it is what charge? It's positive, negative. So repulsion. Positive, negative are affection. They have love each other. If it is opposite sign, they repel each other. They will not attract each other. Next here, Q2, what a minus. So minus q1. So what will happen? This, what will happen to minus q1? I find my friend. I find my friend. My friend is minus q2. My charge is negative. So I will move. I will run away towards that friend. I will run away. I will run towards the friend. I will run towards the friend. That is what given as f2. F2 is k into q1 q2. If you note here, I have taken positive charges. Both are positive. No negative charges. I can write minus q1 into q2. No, that is wrong. You have to write q1 into q2 divided by distance between the b square. Now if you're asking what is the direction of force, this is a force. Never take minus sign into the equation. Okay, now we have F1 force will be here. We know this angle is called theta. Then the opposite angle is also called theta. So the total angle here is 90 degree. So if it is theta, this part is nothing but 90 minus theta. So you have F1 component, F1 the adjacent side. Adjacent side means I am moving towards this side. Towards this side. So what will come? F1 into cos theta. But what is theta here? Towards that side is what? 90 minus theta. So cos of 90 minus theta. But this side was what will come? F1 cos theta will come. But towards this side what will come? F1 into cos of 90 minus theta. Here it is theta. So F1 cos theta. Here it is 90 minus theta. So F1 cos 90 minus theta. So now you have two forces in the direction. What are the thing? F1 cos 90 minus theta in one direction and F2 will be here. So which means you have two forces now. You have one forces, nothing but your F2, and you have the another forces that is nothing but F1 cos of 90 minus theta. F1 cos of 90. That's not clear, so let me write a little leftward because I will not reach the page border. Here we have F1 and here we have F2. F1 is F1 cos of 90 minus theta. Now this is my final state. Now this is my final state. Two forces, two vectors are acting in the same direction. What should I will do? I need to find out the vector sum. How to find out the vector sum? F net vector. Two forces in the same direction, two vector in the same direction. What should I do? I will add F1 cos 90 minus theta plus F2. Cos 90 minus theta is called what? Sin theta. Okay, it's called sin theta. So cos 90 minus theta is called sin theta. So F1 sin theta into F plus F2. F1 is k q1 q3 by a square into sin theta. F2 is k q1 q2 by b square. This is a common term on k q1 k q1. Take it outside. And here balance is what? Q3. Balance is this one. Q3 sin theta by a square. Here balance is what? Q2 by b square. Here Q2 by b square. Okay, you are adding the vector sum, but here this sign should not come here, right? The sign should not come here. So k q1 q3 sin theta divided by a square plus q2 divided by b square. This is the answer for the question. So what is matches with this option number? So let's see. Q3 sin theta by a square. This is our final option. Q3 sin theta by a square plus Q2 by b square. So Q3 sin theta by a square plus Q2 divided by b square. Option number 3. Anyway, plus ആണ്. So Q3 sin theta term with a plus b square. Another option number 3. So we have option number 3 is the correct answer for this question. Option number 3 is the correct answer. So what we have done, we have two forces because of the three charges, two forces. See, you analyze will be here how many charges? One charge, one charge, one charge. You have three charges, but you have how many forces? F2 and F4. Two forces. So we need to find out the vector sum. To find out the vector sum, what you need to do? You need to understand our key concept. Two forces same direction, will add it up. Two forces opposite direction, will subtract it up. If two forces making an angle, then we have to find out this one. So the easy method is option number 1 and option number 2. So we can convert certain diagram into option number 1 format and option number 2 format. So what we'll do in this case, you already have F2 will be here, you already have F1 will be here, and you taken F1 into in this direction. So you have F1 cos 90 minus theta, and here also here we have F1 cos theta. Question is asking only the X component. So here we have a Y component also. What is the Y component? F1 cos theta. You can expect maybe the next year question exactly like this, but they will ask what is the Y component. If they're asking what is a Y component, means you have to take only F1 cos theta only. This headache is not there. Here you have to add it up. These two forces will be here. F1 cos 90 minus theta plus F2. Then you will add it, because the question is asking what is the X component. Maybe tomorrow the question will ask what is a Y component. Situation is entirely different. So it's very important you understand the question. Okay. All the things which I have told you, so all the things which we have discussed in the part 1 video and part 2 video is already taken in a very detailed way. In our YouTube channel, you can see electric charges, electric field videos. Our full video is available from base to advanced level, scratch level, full videos, and you can go and watch. If you have any doubt in any part, any sections, you can watch it. Okay, it is exactly going like NCERT sections, but we are doing more problem discussion also. And in this revision series also, what we have done, we are strictly stick to NCERT each section by section question we discussed. So if you watch this video also, it's a complete revision for you for electric charges and field. Let's move to the 30th question. Two pith balls carrying equal charges are suspended from a common point by a string of equal length. They are in equilibrium separation between them is R. Equilibrium separation means it's not moving, it is at rest. F net equal to 0. I told in the first part of the video. Now the strings are high rigidly clamped. Rigidly means tightly clamped at halfway the height in the second diagram. Equilibrium separation now become R dash. What is the value of R dash they are asking? This question is exactly coming from NCERT section number 1.5 Coulomb'S law. But this is not a straight away question. This question is also asked as a previous year question for entrance examination. But what is a specialty? Here lot of trickiness they are placed will be there. Little bit of mathematics knowledge also required. Let's see. Let's learn some theory behind this one. First of all, always the Coulomb's law. F equal to K into Q1 Q2 by R square. And some basics of mathematics, you must know what is called tan theta. Tan theta in mathematics, opposite side by adjacent side. So let's take a triangle like this one. So if you have a triangle like this, let me raise it, let me make it a beautiful one. Okay, so you have a triangle. Okay, you have a triangle like this, and this angle is called theta, and this is the opposite side. Say let's take it as y, this taken as x, this taken as z. So what will come will be here tan theta equal to opposite side is y and adjacent side is x. Opposite side by adjacent side. So this is called adjacent side, this is called opposite side, this is called hypotenuse in Pythagoras theorem, right? So tan theta is y by x. So these two we need to know. Now we'll solve the problem. See, first diagram and we have the second diagram which I will be here. So this is connected using a string. String will have something called a tension. So this is a T will be here. So this angle I have taken as theta because it's not given in the question, but I taken as theta for myself. So what will happen? This angle is also called a theta. So T is resolved into two components. One is adjacent side is called, always I told, cos theta. The other side is called sin theta. So T cos theta and T sin theta. T is splitted into two components. T cos theta, T sin theta. So it's over. And we have a gravitational force because we are not performing the experiment in space. We are performing in earth. Previous question is told we are taken into space. No, here no such things. We are in air only. We are in earth only. So we have mg. Equal charges q and q. So what will happen? It will repelled with a force called F. So 4 forces will be here in this charge. Similarly, in the right side also 4 charges, but I have skipped that one. I have taken only the left side. Right side same way. So what it is given? It is given they are in equilibrium. Question ഒരു word ഉണ്ട്. They are in equilibrium. Equilibrium means what? I already mentioned this point in already my part 1 video also. If you have not seen, please watch the video also. I can also tell here also. Equilibrium means, suppose I have 2 hands. My one friend is pulling rightward with a force 10 Newton. Left side with a force 10 Newton. Both forces are equal means I am not moving rightward. I am not moving leftward. I am remains there. So which means left right force equal to 0. Top bottom force equal to 0. The body is in equilibrium. Body is rest position. So which means we are analyzing T sin theta. And the opposite on F. So T sin theta equal to F. F means what? KQ square. Coulomb's law. KQ square by R square. In T cos theta. T cos theta is equal to what is equal to mg. So we have written these two equations. We are dividing equation number 1 divided by equation number 2. What is sin theta by cos theta in mathematics is called tan theta. So left side divided, right side also divided. KQ square by R square divided by mg here. So what is tan theta from this diagram? See, from this diagram, what is tan theta? Opposite side by adjacent side. What is opposite side? R by 2. What is adjacent side? Y. This is hypotenuse. Say for example, Z. So R by 2 by Y. Half on it. Half on theta. So R by 2 divided by Y. Tan theta. Right side like KQ square by R square into divide by mg means mg will come downward. So here I solved for R, this I multiplied here. So R cube is equal to, here 2 and y will be denominator, will go to numerator here. So R cube is equal to 2kq square y by mg. We got the equation. Same method we are applying towards the next set of diagram. Here we have theta dash, angle changes. Distance is r dash by 2. We have t sin theta. We have the force. So t sin theta is equal to what will come? T sin theta. Rather, here we have one difference. What is called t sin theta dash. T cos theta dash. So how will the diagram will come? Let's write. T sin theta dash will be equal to k into what is the charge? Q square by r dash square. Ini t cos theta dash. T cos, opposite forces are equal. So T cos theta dash is equal to what? T cos theta is equal to mg. So equation number 3, equation number 4. Now equation number 3 divided by equation number 4, we will get it as. What will get it as? We know we have now T cos theta mg equal on T sin theta dash f in equal on. Next we divided these two. So tan theta dash, the sin theta dash by cos theta dash, tan theta dash will come. Okay, so let's divide. Tan theta dash is equal to kq square by r dash square divided by mg. So we are simplified, mg will come downward. Next I find out an equation for r dash cube. R dash cube equal to kq square y by mg. Okay, now the trick is coming. We have two set of diagram. For two set of diagram, we know it is in equilibrium because question is always stating equilibrium. See, for first part, question is given equilibrium separation. Again, it's given equilibrium separation. Here equilibrium separation is R. Here equilibrium separation is R dash. So here also it is in equilibrium. Here also it is in equilibrium. That's what we can equate right force, left force, top force, bottom force. Okay, so always the equilibrium R dash. So always the body is in equilibrium. So based on that understanding, what we are going to do now, we know this is a cases. Now the important thing is happening. See, kq square by mg. This is nothing but equal to kq square by mg here. Okay, so r cube equal to part substitute r cube equal to this one. See, kq square y by mg is another this part. So this part I can replace with the r dash cube. That's what I have written here. R cube equal to 2R dash cube. So I need to find out R dash. R dash means R cube by 2 and the cube root. That's cube root. So if you take cube root, R cube in the root, what will come? R cube in the root is nothing but R. It's not R cube, it is R. And a 2 in the cube root, 2 raised to 1 by 3. So R dash is equal to R by 2 raised to 1 by 3. Option number 3 is the correct answer. Let's go to option number 3. Option number 3 is this one. R by cube root of 2. R by cube, because all options are very confusing to each other. So you will be very careful while you are answering. R by cube root 2. It's important. Okay. Okay, so let's move to the next question. Question number 14. Question number 14 is from electric field. NCERT section number 1.12, continuous charge distribution. That's what in the beginning of the video I told. This is 100% based on NCERT. I have not taken a single question out of NCERT. No. It's a big no. So let's go. Two parallel thin film metal sheet have equal surface charge density. We are learning a new term called surface charge density sigma of opposite sign. Sigma, one is positive, another is negative. Electric field between these sheet will be now you are taking a wire, that is called continuous charge distribution, because it has charge in every point. If you have taken a sheet, a metal sheet, you have charges on every point. That's what the heading is called, continuous charge distribution. A very detailed video is available in YouTube for the theory section. Okay. Next, we are learning some key point which I already taken in the theory section, but we will revise it. Let's take, we have a single sheet will be here and it has a charges of plus. Electric field lines are always going away from plus charge and electric field lines are always coming towards minus charge. Here it is a plus charge. So electric field lines are going away from positive charges. So electric field here and electric field here equal to sigma divided by 2 epsilon 0. This is for a single sheet. That left right. Sigma is called what? What is called a sigma? Sigma is called charge by area. Sigma is called charge by area. Charge divided by surface area. That is called surface charge density. The case number 1 we learned. Look into the case number 2. Case number 2, the difference is where we have two charges. One is plus and another is also plus. Both are plus. Now I have taken one sheet will be here. One sheet will be here. Sheet number 1 will be here and sheet number 2 will be here. Due to sheet number 1, electric fields are away. Due to sheet number 2, electric fields are away. From 2, electric fields are going out from sheet number 2. From sheet number 1 also. So here exactly at the center, or there is a chance electric in between the two sheets, electric field lines are opposite. One electric field is going like this, another electric field is going like this. What will happen? Both electric fields will cancel, vector on, so cancelling. Both are equal value on, because sigma by epsilon 0 on a formula. It has no dependencies with any distance r. There is no dependency with the r, because it has equal charge in between the two charges, electric field equal to 0. In the next, look into the right hand side. From sheet 1, electric field is going away from the sheet. From sheet number 2, electric fields going are away. So now sheet number 1 and sheet number 2, you have the electric fields which are going away. Two electric fields are going in same direction. Two vectors are in same direction. What you will do? You will add it up. E net vector sum. Sigma by 2 epsilon 0. Sigma by 2 epsilon 0. Answer is sigma by epsilon 0. Left side also we look into. Because of one, electric fields are going away. Because of two, electric fields are going away. So we have 1 and 2. Two electric fields are going in same direction, but it is towards left side. So what is it? Again the E net sigma by epsilon 0, sigma by epsilon 0. So the same things will come in the left side also. Sigma by epsilon 0, sigma by epsilon 0 in the right side, and the middle is equal to 0. Case number 3. You have a metal sheet, but one is positive charges, one is negative charges. What will happen? At the center or in between the sheets, one number electric field lines are attracted or towards that one. But from the two electric field lines are going away. So 1 and 2 in the same direction. We are adding up sigma by 2 epsilon 0, sigma by 2 epsilon 0. What will come? Sigma by epsilon 0 in between. But right side, for one electric field lines are coming towards the sheet. For two electric field lines are going away from the sheet. For one electric field lines are coming inside, for two electric field lines are going out. So both are opposite direction, equal magnitude, E net equal to 0. Left side, electric field lines from 2 is going outside, for 1 is coming inside. So 1 and 2 in both opposite direction, equal magnitude, E net equal to 0. See, one sheet positive, one sheet negative. In between we have electric field. Either side we have electric field equal to 0. But in case number 2, you have electric field at the center equal to 0. But you have electric field at left side, you have electric field at other side. Case number 4, if you are taking a single sheet, what's the direction of electric field? Electric fields are coming towards the sheet. So here we have sigma by 2 epsilon 0, sigma by 2 epsilon 0. No, its problem is solved. A single sheet, one value. So case number 4, if you look, electric fields are coming towards the sheet. But if you look, case number 1, electric field lines are going away. Only the different magnitude is same. Because one is positive, another one is negative. Two sheets, remember, the case is entirely different. That's what we are described in case number 2 and case number 3. Important on it. Direction based that we are calculating the total value. If it is same direction, if it is in the same directions, what we'll do? We'll adding up each other. We are adding up each other. We are subtracting opposite direction. Subtracting, adding. Okay, for addition. So what is the subtraction? Subtraction in 2 places. Same direction, addition. Okay, now let's read our question once again. Two parallel thin metal sheet having equal surface charge density, same surface charge density, 26.4 into 10 power minus 12. Surface charge density means a charge by area of that particular sheet. Each sheet will have one surface charge density. That is called sigma. It may be sigma 1 and sigma 2, but they have given equal surface charge density, which means sigma and sigma, of opposite sign, which means one is positive and one is negative. Electric field between the sheets. See, so case number 3 is the following. One is positive and another one is negative. So left side electric field is 0, right side electric field is 0, but electric field will be where available? Only at the in between the sheet. So what is the formula here? Sigma by epsilon 0. Question is asking electric field between the sheet. Between the sheet means this formula. Two opposite sign. Question is also given, right? So they have opposite sign and electric field between the sheet. So opposite sign between the sheet so it is sigma by epsilon 0. Direct formula substitution here also I described because of one electric field inside, because of two electric field is away from this one. So we are adding sigma by 2 epsilon 0, sigma by epsilon 0, sigma by epsilon 0. Sigma value is already given in the question, 26.4 into 10 power minus 12 divided by 8.85 into 10 power minus 12. So 3 Newton per Coulomb. 3 Newton per Coulomb is the correct answer for this question. So that is option number 3 is the right answer for this question. Okay, 3 Newton per Coulomb. Question number 14, answer is 3 Newton per Coulomb. This question is taken from NCERT section number 1.12 continuous charge distribution, specifically surface charge density based question. All theory related to surface charge density is told here. So if you learn this one, over, because we are described the problem here for metal sheet. Metal sheet lana sigma varnathu. Metal sheet based all problem you can solve based on this single key point. Okay, now let's move to the next part of the question. Question number 15. Question number 15 I have taken from electric field lines. NCERT section electric field lines. The question is coming. Let's read the question. To spatial distribution of electric field line due to charge A and B as shown in the figure. Which one of the following statement is correct? If it and here we have B is also. Which one of the following statement is correct? Question is given multiple options, but before we are going to the options, let's understand some theory behind this one, which means properties of electric field. You must learn this one. It's very important. If you learn this one, you have a high chance to get one questions to be answered in the final NEET examination or JEE examination. I will explain one by one. What is given? Field lines will never intersect each other, which means you have a field line, electric field line like this, and you have an electric field line like this, then this is wrong. This will never cross each other. Electric field lines will never cross each other. And first point. Let's move to the second point. They are perpendicular to the surface. For example, you have a metal sheet like this one, then the electric field is like this, perpendicular. This is correct. Electric field will never go like this. This is wrong. Electric field is always perpendicular to the sheet. Suppose if you have a sheet is placed like this, you have sheet, then electric field is always like this, making 90 degree to the sheet. Electric field never go like this. This is wrong. This is not 90 degree. So electric field is always perpendicular to the surface charge. This have a surface charge of sigma. So electric field is always making an angle of 90 degree. Question number 3. Not question number 3. Property number 3. The fields are strong when the lines are close to each other and weak when the field lines are move apart from each other. Which means if you have a 6Q charge, if you have a Q charge, then 6Q charge, you have more number of electric field lines will be here. More number of electric field lines. Positive means it is going away. Positive means going away. Positive means going away. But if you have a small q, you have very few charge lines like this one. If you have 4q, then what will happen? You have large number of charges will be here. Okay, that's a difference. So more charge in the value, if it is very high, you have more number of electric field lines. Let's say one example, one 4q, one q charge. So q will have say 1, 2, 3 lines, but 4 will have 1, 2, 3, 4, 5, 6, many lines will be here because it's more stronger. Next one, number of field lines are directly proportional to magnitude of the charges, same way what we have described. Fifth one, electric field lines start from positive charge and ends at negative charge, which means you have a plus q, you have a minus q. Electric field lines are start from positive and ends at negative. So if you are taking two charges, say plus q and minus q, electric field lines are going like this. See, starting from positive, ending at negative. And we have the sixth point. If the charge is single, then they start or end at infinity. If you have a single charge, they starts and go into infinity because it has no ending point. If you have a negative charge, a single charge, they start from infinity and end at minus charge. That is the sixth point. Seventh point, the line of curves are continuous in charge-free regions. Lines are continuous, which means plus q and you have a minus q. So here the charges are continuous. Continuous means this line. This line is called continuous. Okay, so we have understood this one. Now we'll look into here to our problem. Now if you see, if you look into first problem, the first thing which just comes to your mind means here, see, here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines will be here. But here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One side you have 10 lines, other side you have 13 lines. So which charge is more powerful? More magnitude or more powerful charges will have more number of electric field line. So the value of magnitude of B is definitely greater than magnitude of B is greater than magnitude of A, no doubt, because B has lots of number of lines are here, more number of lines here. So magnitude of B were the option number 1, option number 3, option number 4. Next, for A, electric field lines are coming inside for B, electric field lines are going outside. Outside പോകുമ്പോൾ what is called B? B is positive. B is positive and A is negative. See, A is negative, B is positive. B value is higher than A value. B, because more number of electric field means more magnitude. And B is positive because electric field lines are going out. A is negative because electric field lines are coming inside. B is going, electric field lines are going out. So B is positive, A is negative, and B value is greater than A. So option number 1 is the correct answer for this problem. Okay, it's a very simple question, just visual analysis. There is no mathematical calculation. Only you have to learn the properties which I have told here, very important. Okay, so correct answer based on property number 4 and 5. But is a property number 4, number of field line directly proportional to magnitude of charges? Yes, more charges means more field lines, electric field lines start from positive and ends at negative. So based on these two property, the question is formulated, and the question is asked from NCERT section number 1.8 electric field lines, where they have given the properties of electric field lines. I just collected each and every point and listed over here. Okay, perfect. Electric charges, electric field is not a very big tight chapter. It's a very simple chapter, but you have to learn a lot from this one because the volume of chapter is a little bit higher. But it is very easy to understand, very easy to score if you are learning conceptually. So I strongly recommend you to watch out all the theory video and make a proper note, then attend the revision videos, or you can also attend the revision videos, and when you have time, you slowly start to watch our videos. Definitely 100% I am guarantee it will be helpful for you. It will never a time waste for you because it is pure 100%. It's a free service. It's a free video for you. So definitely you can watch this video whenever you are sitting there. And if you like the video, and if you want to attend more of our offline classes, and if you want to take our section test, model test, or weekly test, then definitely you can contact our officers. And if you like the approach what we are following, and if you're interested, definitely you can join for our courses, and you can take the benefit of the course. Okay, so let's go to the question number 16. I'm not telling this is like a marketing strategy, but I'm really telling you, go to our playlist, you see our videos, you see our class lecture videos, you see our question discussion. If you feel it is really worth, just try to take our test series also, because it's definitely will helpful for you. We have like different test series patterns are there, like weekly test, section test, model test, and everything 100% is not available through YouTube, right? Definitely. So there are certain things which are going definitely in the offline classes also. So there are many things were there. So especially the physics and chemistry is a difficult paper for students comparable to biology. So you have to spend a lot of time here. Once you spend, definitely it is easy. You can easily crack NEET. This is not a rocket science at all. First of all, I'm telling. Let's move to question number 16. Electric field at the origin O. You have to calculate electric field will be here. Okay. Oops, my color gone. I have to make it my. Okay. So let's analyze the problem. Then we will come to this problem. Okay. So what it is given in the problem? We have to calculate the electric field. We have to calculate the electric field. Where we need to calculate the electric field? We need to calculate the electric field at the point O. At the point O here. Electric field at the origin due to the circular arc having charge Q. The circular arc in the charge is Q. This is again from NCERT section 1.12, continuous charge distribution. Once again, I'm mentioning you, this is a very important section in NCERT textbook. Okay, before going, so we need to find out electric field will be here because of the arc. Okay, that is a question. So let's learn some theory. First of all, if you take an arc and whose angle equal to phi, total angle equal to phi, then this is not a sheet. This is just an arc. This is just like a string. So lambda equal to Q by L. Lambda is called first term, so that is called linear charge density. I have to make the name will be here. linear charge density. Linear charge density. That is called lambda. We have learned another term is called, right? What is called? Surface charge density. We'll just recollect and write it here. Surface charge density sigma. Do not confuse this between. So sigma, we know it is Q by sigma is called what? Sigma is called small q term, or you can do capital Q, no problem. So small q by area or capital Q by area. And here we have called Q by L, arc in the charge, divide by arc in the length. If you taken here, then this much is its length. It's important. Okay. Positive charge are, if it is positive charge, direction is always away from the arc. Just remember like this. For time being, I will explain very detail later. So vector E equal to electric field in the value. You should remember this formula, no other way. So the electric field will be equal to the derivation, and the detailed explanation is available in our lecture video. But at the moment, this is enough for you. Electric field equal to 2k lambda by r into sine phi by 2. What is called r? R is nothing but the arc in the radius on r. Phi is the angle. You know what is called k. K is 1 by 4 pi epsilon 0. That is called k. So you remember this formula, 2k lambda into r into sine phi by 2. Please note this formula, it's important. So we learned a little more. There is some special cases we have to learn. So for example, we have a case 1, we have a circle, or you have a string, you bend it like this and you form a circle. Here what is the angle of phi? What is called phi? Phi is the total angle, and the phi will be equal to 360 degree here. So if you substitute in the formula, what is our formula? E is equal to 2k lambda by r into sine phi by 2. Phi is 360. 360 by 2 sine 180 in the very angle. Sine 180 is 0. Answer equal to 0. Case number 2, we are taking an half circle. Half circle, what is the angle will be here? Tell me what is the angle phi will be here. The phi equal to 180 degree. Okay, so the angle phi is equal to 180 degree. So 180 degree means electric field equal to 2k lambda by sine phi by 2. 180 by 2 means sine 90 will come. What is sine 90 in the value? 1 ആണ്. So 2k lambda by r. But important. K means what? Q by L. Q by L. ഒരു full circle length means 2 pi r ആണ്. So a full circle, the radius r, if it is its length equal to 2 pi r. A full circle and other string, if you take in the string, this has this much length, 2 pi r. Important. This is full circle. Now half circle, what will come? 2 pi r by 2. 2 pi r by 2. That is the length. So Q by L, 2 pi r by 2, 2 cancels. Q by pi r ആണ് lambda value. Very important. Very, very important. Okay, here first case electric field is straight away 0, nothing to do. It's a full string, a positive charge or negative charge, whatever it is, 0. This is a half string. Half string and the value, we have a value will be here. Lambda is what? Q by L. So we have to find out L. L means a full circle. A full circle length means 2 pi r, which means if a string in the starting point and ending point S on. So if you are taking like this, we have S will be here, S O will be here. L equal to 2 pi r. That is string in the length, the perimeter of the circle in mathematics. Same way we are using it here. So Q2 pi r by 2 to 2 cancel, and we have Q by pi r will come. Case 3, you have a quarter circle. Half circle illa, it is just half of the half circle, which means quarter circle. Phi equal to 90 degree, you have phi will be here, and this phi equal to 90 degree. If your phi equal to 90 degree, 2k lambda by sine 90 by 2 means sine 45 degree will come. What is the value? Sine 45, 1 by root 2, you know, you can substitute and you can find the answer. But I just written like this one. So this is a case 3. Okay, so we can find out the magnitude. But if you look into the option, everywhere they are given the magnitude. But additionally, they have given I, J, minus J, minus J. What is this called? This is called vector. This means it's a direction. Plus I means positive X. Minus J means minus Y direction. minus j minus y. J means positive y. I means positive x. Direction arena. Because we have, this is called plus j, this is called minus j, this is called plus I, this is called minus I. This is called positive x, this is called minus x, this is called minus y, this is called positive y. We should know this. Okay. So now we learned the theory, we find how to find out the magnitude. Now we are going to find out direction of E. How we can calculate direction of E? Very simple way. We have to use simple bit of our logic here. Let's see. Suppose this is a positive charges over here. Everybody is positive. So this you have a lot of positive charges will be here. Lot of positive bubbles throughout. Positive charges. I taken one positive charges. This will give an electric field. Positive means away from this one. Okay. So you have this component. Say for example, I have taken this as theta. So you have resolved this into two components. One is the adjacent component. Say this is f mean. This is called f cos theta and this is called f sin theta. Similarly, the other side you taken another charge. This will also away from the charge electric field line. This also completed as theta, f cos theta and f sin theta. So what will happen? If you see overall this diagram, say you can see there are if you take another line, this will go like this. This will be resolved into two components. If you go like this, this will be resolved into another component. If you take any charges, you always have left component. You always have right component. Suppose if you take one charge here, similar charge if you take on the other side, in the center. If you take one charge here, you take another charge here. If you take one charge here, you take another charge. So it is like a symmetrical structure. So you have a left side electric field, you have a right side electric field. Definitely these two will cancel each other. Same magnitude. Okay. Instead of f cos theta, you can say E cos theta because it is electric field. I told f cos theta. No, because it's not forced. They're asking electric field. By mistake I told. Sorry for that. And here it is E cos theta. For example, here it is E cos theta or E sin theta or whatever it is. This electric field and this electric fields are equal. Definitely they will cancel. Always they will cancel. Right equal to left, right equal to left, right equal to left, right equal to left. It will cancel. But you have many electric field which are going in this direction. Many electric field which are going in this direction. They will add it up. Added up the vector E. So the direction will be in what direction finally? Minus J direction. It's very important. Direction is minus J direction. Okay. Now, if the question is asking if you have placed, suppose if the question is asking if you have placed like this, then what will happen? This electric field cancel, this electric field cancel. Always the electric field is in this direction. All this left and right electric fields are cancelled. All these are cancel. Only this will be added up. So what is the direction here in this case? Positive J. If you have keeping like this, then it's in the positive J direction. All left and right will cancel. But in the question, it is given in another way, upside. So electric fields are always in the down direction. So let's substitute in the formula 2k lambda by r into sine phi by 2. Phi is 180 degree, so it becomes sine 90. Lambda we substituted previously, we learned it is called q by pi r. How lambda equal to q by pi r? We have learned here q by 2 pi r, length is 2 pi r by 2. 2 pi r means full circle and a half pi r. So q by pi r we are substituted over here. So q by pi r lambda 2k by r, sine 90 is 1. So here it is 2q by pi r square. Here pi r square, k and value 1 by 4 pi epsilon 0. So 2 and 4 get cancelled. So what will come? 2 into here 2 will come, pi into pi square epsilon 0 r square into q. Direction is what? Minus j. Very important. Everybody will find out the magnitude because they have learned this formula by heart and they know, okay, I have to put it like this, then they will put it like this, but direction is important. It's minus j. Q divided by 2 pi square epsilon 0 r square. Option is 2 minus j direction. Let me see whether option is correct, whether I have written is correct or not. Option number 2. Yes, option number 2 is minus j. Minus j, we have two options. But denominator 2 is correct, 4 is wrong. What we have seen now. So option number 2 is the correct answer. Q divided by 2 pi square epsilon 0 r square. Important. Let's go to the next problem. I hope you understanding each and everything. Next one, 17th question in the part 2 video. At what distance from wire 1? It's not a sheet, it's a wire. Wire no what will come? Lambda 1 we learned linear charge density. Sheet in a surface charge density. Sheet number, line number 1 and line number 2. Wire number 1 and wire number 2. The electric field intensity is at what distance from the wire 1? At what distance from wire 1? Electric field intensity is 0. Electric field intensity is 0 at from lambda 1 and lambda 2 both are different charge density, not the same. Same angle center is 0. It's not at the center, definitely. It is at some other distance from the center, from the lambda 1. It's not at the center. So where that point? We need to calculate. Why it is not? Because lambda 1 and lambda 2 is different magnitude. Same magnitude, center is 0. Same magnitude, because both are positive means one electric field lines will go like this, one electric field lines will go like this. At the center it is equal to 0. But now the surface charge not the surface charge, linear charge density is different, lambda 1 and lambda 2. This is also from the section of continuous charge distribution from NCERT section. The thing is like that linear charge density is asked as a question here previously. Surface charge density we have seen. Okay, we learned some key point behind this one. Electric field due to a line charge, important. Electric field due to a line charge 2k lambda by r. You must remember this formula. Theory, detailed explanation available in the theory sections, but for this problem, this kind of questions you must remember 2k lambda by r. We'll go with this one. We know E net equal to 0. So electric field due to 1 right side, electric field 2 left side. Because it's positive charges, electric field lines are going away, electric field lines are going away. Both are in opposite direction. Okay. Or total electric field equal to 0. We can say total electric field will be equal to 0. So how we'll calculate? How we are calculating? So line charge density, they just told lambda 1 and lambda 2. They have never told it's positive or negative, whatever it is, they have not told. So I have just taken like electric field due to 1 is E1, electric field due to 2 is E1. They told it is 0. At which point? I don't know. I have taken the point as called x, another point as r minus x, balanced distance. Total distance between them is constantly given, it is given as r. Then it's given as r. So x balance part is r. So E1 is 2k lambda 1 by x electric field at this point because of wire 1, then E1. Because of wire 2, 2k lambda 2 by r minus x equal to 0. Simplify, 2k cancel. Lambda 1 by x, lambda 2 by r minus x. I have taken to the right side, lambda 1 by x equal to minus lambda 2 by r minus x. Simplify, I am doing the cross multiplication here. So lambda 1 into r, lambda 1 into x, that minus minus lambda 2 x. X in the terms I am taken to left side, x in left side, x equal to lambda 2 minus lambda 1 r. X equal to lambda 1 r by lambda 2 minus lambda 1. Option number 3 is the right answer. Simple if you know the formula. Electric field at what point it is equal to 0? For a line charge 2k lambda by r. That's a formula. Substituted here, we taken one point as x, then we calculated the x E net equal to 0. So electric field E is equal to 0 where? At this particular point. Okay, that is a logic behind this question. So this is matches with the option number 2, lambda 1 r by lambda 1 plus lambda 2. Lambda 1 r divided by lambda 2 minus lambda 1. So which means what? Option number 3 is the right answer, not 2. Option number 3. Lambda 1 r divided by lambda 2 minus lambda 1. Electric field is 0. At what distance from wire 1? At what distance from wire 1? Electric field intensity is 0. I don't know that distance. I have taken that distance is equal to 0. That's it. I don't know that distance. I taken that distance equal to x and electric field equal to 0. Then I calculated the value for this. Let's move to the next problem. Question number 18. Yes, we are in good shape now. Question number 18. NCERT electric field lines questions based on electric field versus the distance graph for a 2-point charge is given by. Electric field versus distance graph for a 2-point charge. What is a 2-point charge? 2-point charge means we have 2 points. We have to calculate, we have to find out the exact graph for the electric field versus the distance. Let's analyze certain things. If you learn the theory, it is very easy. I will tell you. Positive x direction, electric field is positive. Negative x direction, electric field is negative. Okay, I have taken the first case. Q1, Q2 both are positive. Q1 positive, Q2 positive. Both are positive. What will happen? Analyze, think here very correctly. See, electric field lines, first I am taking this left, some starting from left. This is the red line. Electric field lines are going away. What direction it is going? It is going to, oops, it's minimized. Let me make it big. Okay. So perfect. Now the electric field is going in the minus x direction, which means electric field is what? Negative. Electric field negative means here we are plotting the graph between electric field versus x versus minus x directional. So here electric fields lines are going left. Left to form electric field is what value? Negative. So it should start from here. Starting and going like this. Why it is coming like this? Why it's going to infinity? We know the basic formula for electric field intensity. Electric field intensity equal to KQ by, tell me, what is KQ by R square? So electric field is proportional to 1 by R square. 1 by R square. So the nature of the graph, it's a quadratic. Electric field is proportional to 1 by R square. This is the parabolic relationship in mathematics. This is called parabolic nature. Parabolic nature. The graph will another. This is actually the parabolic nature. Parabolic nature means it is a quadratic relation, right? E is proportional to 1 by R square. E is proportional to 1 by R square means it's a parabolic structure. Y is equal to 4x square. The graph we have learned in 10th mathematics. Quadratic equations always it is parabolic nature. The graph is like a parabolic shape here. Okay, graph is like a parabolic. So here remember, when distance equal to 0, electric field is what? Infinity, very high. So when the distance here, distance is 0, here distance 1 2 3 and going, and here is like thousands or hundreds of kilometers. Here it's like hundreds of kilometers. So at the origin, I'm sorry, my eye is irritating a little bit. Very sorry. Okay. So e point electric field is infinity. Why? Distance is 0. When distance is 0, electric field is infinity. Distance is 0. That's what the graph is going to infinity here. Graph is going to infinity. But when distance is increasing, electric field is reducing. So electric field in the graph. So electric fields are reducing and going. Okay. So it is not going to 0. So it is going like this. In the right side, right side we have the blue color. Electric field lines are going right side because it is positive charge. Right side means what? Electric field is positive, direction is positive x. So when distance is equal to 0, electric field start from infinity. When distance increases, electric field reduces like this. Okay, but other side we have plus Q2. Electric field going away. Away means what direction? Minus, negative minus negative. So electric fields are going from minus. Distance increases, electric field decreases, and both are meeting here. Both are crossing each other. Exactly at the center, this is the electric field. Q1 electric field and Q2 electric fields are equal exactly at the center, and here E equal to 0. I can write like this one. Here E equal to 0 at the center. Now we look into the left side. Here for this charge, electric field lines are going right side. Right side means electric field is positive, positive x direction. At x is equal to 0, electric field equal to infinity. Now what will happen? X is increases, electric field is reduces towards left side. This is what is happening. So this is a graph for Q1 is positive and Q2 is positive. Both are positive. That's what Q1, Q2 both are positives. Let's analyze the other diagram also. Q1 positive, Q2 negative. Q1 positive. So left and we are starting. Electric field lines are going left side. So electric field is negative. So graph is like this. Right side electric field is going right side, positive x direction. So electric field starting from positive y. So this is like what is called plus E. This is called minus E. This is called minus x. This is called plus x. We are going to the next charge. Minus Q2. Electric field lines are coming inside. Left and right. So left to electric field lines are coming inside. When distance equal to 0, electric field is equal to infinity. Electric field equal to infinity. When x is equal to 0, E is equal to infinity. But it is moving in what direction? Positive x direction. That's what it is, plus E here. Okay. So this is also plus E. This is also minus E. In the right side we'll analyze. Right side also will analyze. Here it is negative, minus x direction. So electric field is negative. X is equal to 0, E is minus infinity, starting from here. Going like this. When x is very high, electric field is 0, almost 0, approaches to 0. That's what the blue line graph. Next graph. Q1, Q2 both are negative. Both are negative. So here let me mark plus E. This is minus E, plus E equal to 0. Let's analyze. Electric field negative charge on inside, everywhere inside. Left charge first will inside. Inside means this is what direction? Positive x direction. Right side load on positive x where electric field is positive. Starting from positive and going to 0 from infinity to 0. In right side, it's coming left side. Left side means electric field is negative, coming like this. Next charge Q2. Electric field is going right side. Right side means plus x. Plus x means plus E. Plus E. So plus E is going to start. In E side. This side means it is left side. Left side going means minus x. So minus E. When x is equal to 0, electric field equal to minus infinity. When it is increases, what will happen? X is very high. Electric field is approximately equal to 0. Okay. So graph is like this. Exactly at the center here, as I told, it is always equal to 0. So from this key point, it is clear that option number 4 is the correct answer. Option number 4. This match Q1, Q2 both are negative. Negative strips 1 and here 1, 4 for example if I given. Let me see what is the graph for this one. So this is a graph. Q1 is negative, Q2 is negative. Option number 4 on another. Strips. Then at the center we have here. Okay, this is not exactly at the center. Actually, this graph should cut exactly at the center if both are equal magnitude. Now you say these are not equal magnitude, both are different magnitude. So different magnitude, it is not cutting exactly at the center. It is cutting at this point. The graph is cutting at this point because it's not exactly at the magnitude. The cutting point is equal to this point. Electric field is equal to 0, always nearer to the lower charge. Very important. Always nearer to the lower charge, not to the higher charge. Electric field in the intensity, because E is proportional to Q. When Q is less, electric field is also less. When Q is very much less, electric field is very much less. So electric field is always 0, nearer to the lowest charge. If Q1 and Q2 both having equal charge, then at the center electric field is equal to 0. Here not at the center. Okay, that's an important point. So option Q1 is negative and Q2 is negative because the same structure of the graph. Okay, here 1 and 4, say for example, other match another 1 and 4 match another this graph 1 and 4 q1 and q2 both are negative cases. Important one. Let's move to the 19th question. This question is taken from NCERT section number 171. Electric field due to system of charges. Electric field due to system of charges. System of charges means many charges. We have learned forces due to multiple charges. Same concept to apply will be here. Electric field due to multiple charges or system of charges. Figure shows a regular hexagon. Regular hexagon. Hexagon means how much side will be here. 6 side. 1, 2, 3, 4, 5, 6. All are hexagons. In which of the following cases electric field at the center equal to 0? All cases we have to analyze, then we have to find out electric field at the center. Let me say some theory behind this one. Electric field lines due to multiple charges. See, this is plus q, this is plus q. Electric field lines going like this, electric field lines are going like this, opposite direction. For the first one going away, from the second one going away, electric field at the center equal to 0. If it's a different magnitude, say plus 4q and plus 4q, here is a strong electric field. That's what I had written as a thick line. Here it is a less thick line because less electric field. So electric field will be equal to 0 nearer to the lowest charge. Okay, but exactly at the center 4q plus q, electric field at the center is never equal to 0 because field strength is higher for plus q. So plus q will push, and whenever charges value q is less, electric field is less. So electric field is equal to 0 near to lowest charge, not at the center. Central when both the charges are equal. Our concept we are going. Let's see. Electric field is stronger. I used thick lines. Say for example here 4q thick line ആണ്, 5q thick line ആണ്, 6q. ഈ 5q ന്റെ ഓപ്പോസിറ്റ് ആണ് 2q വരുന്നത്. സോ ഇതിന്റെ സെന്ററിലോട്ട് വരുമ്പോൾ it will never equal to 0. ഇനി 4q ന്റെ ഓപ്പോസിറ്റ് ആണ് q വരുന്നത്. ഡിഫറെന്റ് തിക്നെസ് ആണ് ഇരിക്കുന്നത്. സോ it will never equal to 0 at the center. 6q ന്റെ ഓപ്പോസിറ്റ് ആണ് 3q, never equal to 0 at the center. So this will E is not equal to 0. In this case, minus q in this direction electric field, so plus q other direction. So two vectors are adding up. Opposite island is 0. So this will never equal to 0. Question number 3. Option number diagram number 3. Diagram number 3 this is going away 2q. Adhe strength charge on opposite 2q. So definitely cancel 0. This charge 2q and the near opposite on 2q, 0 cancel each other. This is q electric field, this q electric field, same strength equal to 0. So if all are cancel each other, option diagram number 3 is the correct answer. Diagram number 3 is given in option number 2 on. We'll see. See, option number 2 is diagram number 3. So electric field at the center is 0 in diagram number 3, which means option number 2. Option number 2, diagram number 3 is the correct answer. Okay, very interesting problem. Let's simply look into option number 4 also. See, here 2q very thick, oops. Okay, 2q very thick line, but opposite we have q, so it will never equal to 0. Here also 2q very thick line, 2q, okay, it is equal to 0. Q equal line cancel equal to 0. But problem is here, 2q is very thick, but q is not strong enough. Suppose here if you have 2q will come, then this also an option for this question. But unfortunately that is not given. So option number or diagram number 3, option number 2 is the correct answer. Question number 19. Let's move to the next problem. Question number 20. This is the last questions in the part 2 video. Electric lines. Question number 20. Which of the following pattern of electric lines of force is not possible? If you look here, electric field lines are parallel to each other. Yes, it is possible. They are not crossing each other. Electric field lines from a positive charges are going away. This may be a positive charges. This is an electric field lines are starting from a positive charges. Yes, it's possible if it is a plus q. Here like this. With plus q charges based in here we have everywhere line like this. If you cut this much portions, then this is also possible like this, or this is also possible like this. But electric field lines will never crosses each other. We have some points will be here. Field lines will never intersect because one field line is not intersect. This is intersection. one field lines, next field line, intersection. This is not possible. This cutting is not possible. See, a field line starting here and ending at the here. So ending here means intersection. This is not possible. Field lines will never intersect each other. Which diagram it is intersecting? See, starting here, ending here. So closed loop. Starting here, ending here. It is touched. Starting here or starting here, ending here. Touched. No. Cross each other. Not possible. So electric field lines will never supposed to cross. This is the question again from properties of electric field lines. We already discovered field lines will never cross each other. According to property number 1, option 3 is the correct answer. Option 3 means which of the following pattern electric lines of force is not possible. This is not possible. This is wrong. Electric field lines will never cross or never cut each other. Hope you understand the things which you have described in this video. So second part of electrostatic electric charges electric field video is over. Now we have discussed 20 questions, especially from Coulomb's law, multiple forces and electric field lines we have discussed, and we have few more questions are left, especially from electric field, because it's a very big topic and we have dipoles and many other topics are coming. I request you to seriously watch this video and make a note, and wherever important equations are told, please make a note of on your formula book. And if you have any doubt or if you want to understand very deeply, as I told, 25 plus videos are available in our YouTube channels. You can go there and you can watch there. It's a very useful. Each and every topics are described as per NCERT, and this is like a revision series, and here also you have questions from NCERT each section. So this you can use it for if you want to learn quickly something. Definitely this will be a word for you to practice it. Okay, I wish you a good luck for your study, and we will see you in the next part of the video at the same time in the next week. Okay, thank you.